Hello everyone. Okay, so now you're welcome to Bailey Tutors YouTube channel. So now on the board you can see that we're about to solve a particular topic on the calculus. You understand? Yes, sorry, we are about to solve a particular question on calculus. So we'll be treating calculus this morning. Do you understand? So now this is the application of what differentiation. We've solved so many questions on calculus. We've treated so many subtopics, you understand, on differentiation. So now you can just go to our YouTube channel to check all these topics. Do you understand now? So now on the board, please let me know if you can see the board. Let me know if you can see the board. Alright now. So now this is the gradient of the curve. Y equals to 3x squared plus 11x plus 7 at the point Pxy. Now, sorry, I want to increase the volume so that you can hear me well. So now, the gradient of the curve y equals to 3x squared plus 11x plus 7 at the point Pxy is what? Minus 1. We have to find the coordinate of P. Do you understand? So now, this is how we are going to solve it. So y is what? 3x squared plus 11x plus 7. So we want to get our dy dx now. Dy dx equals to, so now I want to differentiate this particular equation. So that will be 6x plus 11. Do you understand now? So we differentiated it now. So now said at the point Pxy equals to minus 1. So now dy dx equals to minus 1. Do you understand? So whenever you see dy dx, you put minus 1. I'm so sure you understand that part now. Alright. So now we have, so since we have dy dx equals to this, so now we'll change our dy dx to what? Minus 1 equals to 6x plus 11. Have you seen that now? So now we are going to collect the like terms from here now. So now let's collect the like terms. So now minus 11, so minus 1 I mean. So this 11 moved to this side becomes minus 11 equals to 6x. So now we have minus 12 equals to 6x. So now divide both sides by what? 6. So x equals to minus 2. Have you seen that now? So our x equals to minus 2. So we want to get our y. Do you understand? We've gotten our x. We want to get our y. Now to get our y, so our y equals to 3x squared plus 11x plus 7. So now wherever you see minus 2, you're going to, wherever you see our x, you're going to change to what? Minus 2. So we're substituting minus 2 for x in this equation. Substitute minus 2 for x so that we can get our y. Okay, so 3 open brackets minus 2 all squared plus 11 minus 2 plus 7. So now minus 2 all squared is what? 4. Okay, plus times minus is minus. 11 times 2 is what? 22 plus 7. 3 times 4 is what? 12 minus 22 plus 7. So now this is what? Minus 10 plus 7. That is what? Minus 3. Alright? So now our x is minus 2 and our y is minus 3. So those are the coordinates. So now you can just say P minus 2 minus 3. So that is our final answer. I'm so sure you understand that. So it's as simple as that. So now we can continue from here now. So now let's move to the next question as well. So now I want to quickly move to the next question. So this is the second question now. Find the differential coefficients of the function y equals to 1 over s squared plus 9 at the points 4, 1 over 25. Alright, so now let's solve this question. So you should be able to see the board now. So now let's solve this question. Solution. So y equals to 1 over s squared plus 9. You understand? So this is a reciprocal question. So now let's change this thing now. So to be x squared plus 9 all raised to the power minus 1, because this is 1 over x squared plus 9. So we want to find the reciprocal of this particular equation. That's why we got minus 1. So now we'll be applying chain rule here now. Applying chain rule. We want to apply chain rule. So if you don't understand what chain rule is, you can just go to our YouTube channel. We've already made a video on that subtopic in differentiation. So applying chain rule. So now our y equals to z raised to power minus 1. Do you understand now? Why our z is what? S squared plus 9. Have you seen that now? So our y is what? Z, you just use z. You want to introduce z now. You understand? So we are introducing z. Y equals to z raised to power this minus 1. Do you understand? Why this z is what? Is this one, this equation, x squared plus 9. So now let's now differentiate the y dz and the z dx. Do you get it now? So let's do that now. The reason why we're using chain rule is because of this reciprocal. So we can't just differentiate just like that. We can't just differentiate. So that's why we're applying chain rule. Do you understand? So now let's continue now. So let's differentiate the y dz. So we now have this minus 1 will come down here. So we have minus 1z. So now you subtract 1 from this minus 1. So we have minus 1 minus 1. So we have minus 1z raised to power minus 2. Have you seen that now? So now let's differentiate the z dx. This z dx. So if we differentiate the z dx, we have what? 2x. Have you seen that now? So our dy dx equals to dz, or let's say dy dz times what? Dy dz times dz dx. Have you seen that now? So if you even cancel dz, you will let dy dx. So that's how we got that. So what is our dy dz? This is it. So that is minus 1z raised to power minus 2 times, what is our dz dx? 2x. So now that gives us this minus 1 times 2x will now be minus 2x z minus 2. And remember our z was what? X squared plus 9. Our z, don't forget, is what? X squared plus 9. So I'm going to replace x squared plus 9 for what? Z. So that is minus 2x is x squared plus 9 raised to power minus 2. Do you understand now? So you can just say minus 2x equals to x squared plus 9 all raised to the power raised to the power what 2. You understand? So when we turn this one, when you make this the reciprocal of this, the what, the minus 2 will change to what, ordinary 2, because we what,